got another video for you in this series focusing on signal processing. Up to this point, we have looked at the spectrum processors, the ones that are focusing on frequency. We've looked at time processors, those that are related to adjustments in time in relation to an original signal. And now we're going to focus on the amplitude processors. Within this range, we're going to be looking at our compressors, our limiters, and our gates in particular, but we'll talk about a few others. So let's go ahead and jump in. We've got amplitude processing right now, again focusing on the volume, the dynamic range, and compression, limiting, gating will be our primary areas of discussion now, but as I said, we'll hit a couple of other things as well. So it's important to recognize what compressors are, and I like to highlight the fact that compressors are generally used to manage the overall volume of a sound source, right? So we can control how loud it is getting. And when we control the loudness, it gives us a chance to also increase the quiet parts. Because if we control the loud parts, we can raise everything up and it makes the quiet parts louder. So a compressor is, in essence, as the name is suggesting, compressing the audio range, the dynamic range of that sound. So compressors are playing with the dynamic range of a signal, and it's reflecting change between what's coming in and what's going out. So let's take a look at some of the components of a compressor that we'll need to learn and manipulate. The first one is the threshold. So the threshold is essentially a setting that we put into place that tells the compressor when we would like it to start. So it's basically a volume level, and we're setting it at a certain point, and we're saying that when the signal goes over that point, then we want the compressor to start working. So the threshold is the point at which the compression will start taking place. Then we've got the ratio. I like to describe the ratio as being the indicator of how much work the compressor is going to be doing. The ratio is going to give us a proportion of change between the input and the output. So in essence, we're going to be sort of monitoring how much over the threshold the signal is going, and the ratio will be saying, well, how much are we going to push back down after it's gone over? We'll clarify that in just a moment. We also have the attack time, which is one of the more challenging pieces or manipulations to get used to using. So the attack time basically tells the compressor how quickly you would like it to work once that signal has gone over the threshold. And of course, since there's an attack time, it makes sense that there would be a release time. And this is doing the opposite. It's basically saying, hey, how quickly do you want the compressor to stop working once that signal's dropped down below the threshold? So those are our four most common adjustments and parameters that we're using when we're doing some compression. I'm going to give you a little example here so that you can see what's going on. The next image here is a graph that I'd like you to pay attention to really quickly. Let's look at the parts of it first. We've got the gray or black dashed line. That's indicated as the threshold. So in this case, the threshold is set at +3. We've got our input level, which is the blue line. So that's representing the signal that's coming into the compressor. So in this case, it's coming in. We're showing it at 0. Then it goes up to +9. The signal runs across, then back down, and then is below the threshold and runs off. And then the dotted red line is showing us what the output is. So now let's take a look at a couple of these points that we want to talk about. Threshold, we know it's set at this +3. So we know the threshold is telling the compressor to start working when the signal goes over that point. Okay, so now we have the ratio. We have to adjust how much work we want to have this compressor do. In other words, how much is it going to push back down in terms of trying to manage the signal? So what we see here is when the signal has gone over +3 to +9, it seems to be dropping down to a +6. So we would call that a 2-to-1 compression. because what's happening here, right, is it's going 6 dB above the threshold, and then once it's working, it's only letting 3 dB go over. So in other words, it's 3 dB over the threshold is passing by. So we dropped from 9 to 6 out of a 6 dB change. So that's half, right? So that's a 2-to-1 ratio. And then we want to get into this idea of the attack time. What's reflected here is the attack time is giving us the period of time during which it's going to start doing that compression, going to start reducing the overall output and getting it to the compressed level we have determined should be the case. So getting from that 9 dB down to the 6 dB, which is where we're saying it should be. And so as long as that input level stays at that +9, once the attack time has passed, then it'll be consistent output, but it'll be consistently 3 dB lower than what the original signal is coming in. And then you see it dropping off when the input signal drops down, in this case to 0. And you'll see that what's happening is the compressor continues to work, but the release time is an indicator of when it will or how long it will take before it stops working, stops pushing down on that signal. So this is just a nice little image of what's going on with the compressor. Now I want to bring attention to a special kind of case with the compression, and that's called a limiter. Now limiter has a ratio preset to infinity. We also have a threshold that we control. It looks the same thing as what we're dealing with a compressor. When we have attack time, it's the same kind of adjustment we have in relation to our compressor. When we have release time, it's the same setup that we have for a compressor. The big difference here is that the ratio is not something we are really controlling anymore. We're saying we're putting it at its maximum. So that way what happens is it doesn't matter how high or low that signal is over the threshold, it's always going to be maintaining the same level coming out of the processor. So that's why they call it a limiter. It's putting a ceiling on top of this sound signal as it's going through. And that's really why you'll hear people talk about compressor limiters quite frequently, because a limiter is really this extreme role in terms of ratio example of a compressor. Ratio is set infinity to 1. That means it doesn't matter how far over the threshold the signal gets, it's always going to let 1 over come by. 1 dB over the original will be allowed through. So that sets a signal across that's a ceiling for the source. Okay, let's jump into the next couple of things, some other amplitude processors. There's one that's called the de-esser. This one is to focus on sibilants, those high S's and T's sounds. You can use the de-esser if you haven't been able to manipulate those or reduce those S's or sibilants in the recording by the placement of the mic. You can use a de-esser to try to minimize it. And basically it's like a compressor, but it's got a filter built in that's focusing on the 2K to 10K range where that S sibilant sound is going to reside. We also have the expander. So unlike the compressor, which is kind of reducing our dynamic range, the expander is extending that dynamic range. There aren't too many instances where we're using that, but they do use it in some mastering, and we'll talk a little bit about that in another video here. I also want to highlight the idea of the noise gate, which is a useful tool. So the noise gate actually closes a channel until the sound level goes over a threshold that we've set. So here's a quick image similar to the one we were just looking at, except it shows us some different things that are going on. Now what happens is a gate is actually keeping a channel closed. So I like to use an example of putting a microphone on a guitar amp. If you've ever listened to a guitar amp before, they tend to be kind of noisy until you start playing. So if you want to eliminate that noise from being in your mix, you might use a gate. The gate will then keep the microphone sound turned off. The channel will be turned off, so it's not entering into the mix until somebody strums that guitar and the level gets high enough and goes over the threshold. Once it goes over the threshold, it just opens and stays open until that sound goes below the threshold again, and then it closes the gate. So basically, we've got a situation where we've got signal coming in, but it's lower than the threshold, and that channel stays closed. As soon as that signal goes above the threshold, the gate opens up, and the sound comes through and gets into your mix. But once it's them dropping below the threshold, again, the gate will close, and that sound will be shut off again. Now, that's something we're using sometimes in live recordings, just to control the number of things that are in the mix and reduce the noise that might be entering into the mix. So the noise gate's a useful tool. We have talked about some of the time processors. You can actually put some noise gates on time processors to create some effects as well, and you can play around in Audition with some different tools like that, some settings that they've got if you'd like. So that takes us through our key amplitude processor: compression, limiting, gating. Remember, compression is going to be controlling the dynamic range. Limiting is also controlling the dynamic range, but it's not flexible in terms of what the peak and the valley will be. It's setting a ceiling at the top of that volume so that you're always got no signal going above a certain point. And of course, there's this gating idea where we're opening and closing a channel in order to control our mix a little bit more. And we will talk about some other aspects of compression and the effects, how they're used in some videos here. You'll see that in the module, we've got a good video that demonstrates some of the impact of a compressor, identifies all of these tools again, the parameters as they're being used. So you'll get to hear some of that in approach. And of course, we're going to be working with these in our labs. So that's the end of this one.